Hey everybody, welcome back. Well, you know I couldn't resist. I had to take that other transformer out and clean it up. So, looks much better now. They look brand new. They cleaned up really well. So, where are we now? Well, the stereo looks like it threw up all over the bench. Parts everywhere. But, you know, this is the way we have to go through it. This thing has to be taken down like this to be able to get to everything to service it. When everything's it's such a small, compact unit that when everything's all put together, you can't really get to things. I mean, you can even see I'm going to have to take this down even further to get to the tone control and so forth on here. So it's just the way this thing is. If you're going to work on one of these and you want to do a full restoration and do a recap and check everything properly and clean the controls, you really kind of have to dig into it like this. So what do I have here? Well, I removed both of these power packs, and it says pure complementary power amplifier. You can see down here. And if you recall, the right channel I could power up and it was fine. The left channel, I hope I'm getting this right, the left channel, when you powered it up, just didn't work. It had all kinds of issues. And after getting into this, I can see where this was serviced at one point in time, especially when I was removing this chip. I could see that it had been worked on. So I think there was a problem with it, and whoever owned it knew it. Now, normally when these things go bad, I mean, I'm not familiar at all with the TA-100WAs, but at least with the STK chips and, you know, the more common ones, usually when they fail, you can measure and at least 2 pins will be shorted. But neither one of these have the pins shorted. And the static resistive measurements on all of these are almost identical, leading me to believe that maybe the chip isn't bad. I'm not sure. But then again, we were getting some pretty serious DC offset. I mean, one side was just not coming up. The problem is these have Darlington connected transistors, so if one of those Darlington pairs has a problem, you know, at the emitter base junction, you probably would not be able to read it from the outside. So who knows? Well, what I've decided to do is, regardless of this, I'm going to leave these out, and until I can test them some other way. I cannot find a data sheet for these either. The only thing that's out there is a data sheet that is not the correct one for these. It's for a Sanken replacement that is not the same layout as these. So I don't even have a data sheet to know what this is supposed to be like. I just have the schematic for the amplifier itself and what little information I could glean from some of the forums out there. So what I ended up doing, as I said, is I went ahead and I ordered those Pyramid audio modules, and they came in. They came in really fast. And I'll show you what they look like. To my surprise, they were already pre-assembled, so there was no assembly required. And I ordered the pair, because of course if I'm going to do one side, I'm going to do the other. And these are so simple, it's ridiculous. There are 2 Darlington transistors, and these are special ones. These are STD03P and 03N. I'll show you what they are here in a second, if I can find my sheet, because I actually printed out. So you can see it's a 4-pin device, and this is a functional diagram of what's inside of it. It's a Darlington pair. It also has the temperature compensation diodes that you could use also as your bias spreader and so forth. All of this is all inside this little case, this little package here. They're pretty stout. I mean, they're good for up to 160 volts, and they're 160 watt maximum dissipation, and pretty stout components. Now, if you try to purchase these, the only place you'll find them, that, you know, when you try to search, will be DigiKey, and it says obsolete, no longer for sale. These are out of production. You can order them still on some of the other websites, like the, you know, overseas ones and so forth, but you have to really watch you're not getting counterfeit ones. I would be a little concerned about that. So I'm not sure how the owner, you know, the person who's manufacturing these, he must have a really good supply of them or something. They weren't really expensive originally, but now they're, you know, if you do find them, they're not always cheap. They can be anywhere. Some places advertise them for $5-6 overseas, which might be fake. Other places are selling them more $15 to $20 range. So who knows? Your guess is good as mine. I'm sure these ones are good, though. These are authentic. But really, all that's on these boards is a PNP and NPN Darlington pack, an LM3, what is it? So 334, which is a constant current source IC, and then a couple of resistors and capacitors. And if you notice, there is a provision on there for a variable resistor, but to my understanding, when these things are produced by the company that makes them, this Pyramid Audio, apparently they adjust the bias as they build these modules and use a fixed resistor in there for that. So there's no bias adjust on these. They just work. So I've heard good things about them. I've never used them. I have used the little module kits. And there's even one on that you can download the Gerber files and print out and make your own for the STK modules, like the 080, 050, and so forth. But this is specific for these TA-100WA pluses. Again, you know, just some resistors on the back. Very simple design. Now, it also came with some instructions that I thought it would be fun to follow along. Some really good information. And basically what they tell you to do is, before you install these, he doesn't want you to plug them in and damage the brand new modules. So there's a test procedure we can go through where we basically bypass the output itself. We're just going to tie the collector of this transistor to the collector of this transistor through a couple of resistors and tie it to this midpoint here, which, if you notice, ties into the what would be the push-pull input of this chip, and then have you power it up, and you can actually get an output on the speaker terminals if you do that. So if you just put that in there, that jumper in there, and you can see I've done that here with these two resistors. I used a couple of 470 ohm resistors. You can power this up and feed a signal into it, which I've done. You can see I have a signal generator, and then I have my scope, and you can pass a signal through it and read the signal. Now, of course, it can't produce any current because these little transistors would never handle it. That's the job of these integrated circuits, is to do the current pass part of it. But if I turn this on and I put a 400 hertz signal on there, and we go over to the oscilloscope, okay, and this is just to rule out that hopefully there's nothing else wrong with the amplifier or with the amp module. And I haven't replaced any capacitors or any components or touched anything. But if we turn this up, and you can see the cap bank is charging up from my power supply as we go, but as it does, you can see it starts to work. And you don't get a perfect waveform here, but as you can see, it is working. And it's hardly drawing any current. It's drawing a couple of milliamps, maybe 10 milliamps at the most. And so it does pass the signal, and if you notice, I'm not getting any DC offset. It's staying pretty well balanced, so I'm pretty happy. And there you have it. So it's working, and that again indicates to me that I think we had a bad module. Because if you remember, I tried to do this test with the module plugged in earlier, and without these jumper resistors, and I would immediately get an enormous DC offset. So one of the rails was just shorting and the other one was, you know, passing through to the, you know, to the output, to the speaker terminal. So I'm going to do this test to the other channel, and then I'm going to clean these modules up and get, you know, change the couple of capacitors. Although I tested the capacitors, I don't know if they're leaky or not, but they don't seem to have a high ESR. The ESR tests good on them. So a couple other things I noticed. Let me disconnect these connectors here so you can see. It's been thunderstorming all day everywhere. I was out of town on a job today, and weather was bad there, and I got back in town home here, and the weather was bad here, and oh boy. So if you look here, these, I'm not sure, but you can see they appear to have been changed at some point in time. These two diodes, and these are right here. Whoop, see them? Okay, and on the other module, they're right here. So you can see here and here. And I'll back you up so you can see it. And when you compare it to the other channel, so look at these ones. These look like 1 watt diodes. You go over to these ones. See how they're different? Much smaller, like 1/2 watt devices. And the board layout is slightly different between the two channels. If you look on this channel, which is the right channel, this has a jumper, and it's jumpering part of the circuit, whereas on here there is no jumper because the way that they're mirror images of one another. They actually were able to get the trace to just go directly over to the pin without the jumper. So the right and left modules are not interchangeable. They have to be on the correct side. You can see. So yeah, I mean, they look real similar, but they're not. Actually, if you lay them on top of one another, they're mirror images. So on this one, the capacitor is on the right. On this one, or I mean, I'm sorry, on the left, if I'm facing this direction, on the left. And if you go this side, capacitors on the right. So they're mirror image boards of one another. So I checked all the resistors and diodes, and I did all these transistors. I checked, you know, statically with diode check. Everything tested good, and as you saw up on the scope, it's passing a signal. There is that little bit of distortion. You know, it's not a nice rounded sine wave, but part of that is because I still have the power supply connected. And again, this was disconnected at some point in time. You could see those leads. I did not do that. When I disconnected it to test it, I disconnected it from the power supply board end, not from this end. So you can see, and somebody did a real janky job putting it back on there, but it's there. So I don't know. I'm going to go over to the other channel. I'm going to do the same test, and we're going to see what happens there. Okay, the other channel is connected. Go over to the scope, and we'll turn this up and wait till the cap bank charges. And you can see it's very similar, same kind of waveform. Still has that little bit of pointiness on the ends, but again, don't worry about that. And remember, I can't run this at full power. My power supply is only good for plus and minus 30 volts or 31 volts, and this thing's running at plus and minus 55 volts. So it's or 57 volts, I should say, plus and minus 57. So that's a big difference. Okay, so I've pulled this module out, and I'm going to rebuild it. And it's becoming more and more obvious that both of these channels had been serviced at some point in time. Because when I went to remove the power leads from these terminals, you could see they had clearly been removed and just kind of draped over the connectors and tack soldered back on, and I'll have to clean this all up. As I said in the last clip, these two diodes here, these are the originals that came with this amp, I believe. And they are a 1S2076, and that crosses over to a 1N4148, which pretty much what I would expect. So that seems normal. Now, on the other side, I don't know what they put in there. They put some kind of diodes there that look larger and so forth. And then this diode over here is a 24 volt 1 watt Zener diode, which is a EQA01-24, and that just crosses over to a standard 24 volt Zener. I'll probably replace that because sometimes as these age, they tend to drift and they're not as stable. That's not always the case, but I've seen enough of these, not just in amplifiers, but just generally used out there, that when these things get this old, they start doing that. So I'll replace them with new ones. And then, I don't know, some of you may or may not have seen these before. These UPA 63H. There's a couple different versions of these and a couple different, signifiers on them. But what they are is, this is an integrated circuit or a package, I should call it, that contains two JFETs in the same package. So they're thermally coupled, they're closely matched, so you could use a matched pair of discrete JFETs to replace this, but these modules are a lot more stable. And this acts as your input amplifier, just as the bipolar transistors normally do in other amplifiers that you probably have seen more commonly. But you can see the configuration here. Looks kind of like a differential pair, but this is your input, this is your feedback, and your DC balance is right here. So it's very similar to the same circuit, only instead of using transistors, they're using, bipolar junction transistors. They're just using JFETs, which will give you a higher input impedance and so forth. But anyway, these are usually good, and you can still get these, I believe. They're still available. I know I have some of these UPAs or mu PAs, however you want to say that. I know I have these in stock. I just don't know if I have the 63s, but they're going to be the same thing pretty much. I doubt that they're bad, though. They're all good. So essentially what we're going to do is we're just going to replace these three capacitors. I'm going to put a 10-turn potentiometer here to make it easier to do DC balance. DC balance with a single turn pot is very finicky quite often, because it's really hard to just barely adjust these things to get it centered. So we're just going to replace that with a 10-turn pot. And I've statically checked the transistors. They're all good, but I'll show you how to do one on camera. I've done this a million times, but some people may not have seen that, and maybe you'd be interested in it. The resistors are all perfect. There's not one that's drifted at all, so we're not going to have to touch any of that. Okay, so to test a transistor, first thing you want to do is determine if the transistor is a PNP or an NPN. Now, with the 2S or with the KS and 2S series, if it's a 2SC or KSC, that C will indicate that it's an NPN transistor. If it's a 2SA or a 2S, I think 2SB, it's a or KSA, that means it's going to be a PNP transistor. So remember the middle letter. If it's NPN, that means emitter base collector, or collector base emitter. The center letter is going to be whether it's positive or negative. So for instance, NPN, the P means positive base. That means you put your positive lead on the base, and then the negative lead would go to your emitter and collector when you're testing it. Now, you don't always know what the configuration of the pins are. Now, you can look up part numbers and things and determine that, but if you don't know what that is, I always start with the negative lead, or I mean with the lead that's going to be for the base. So my base lead is the plus because it's NPN. And I'll just start at one end and I'll go through, and you can see it doesn't read anything. So that's not the base, or this could be bad. We'll see. Now if the base were in the middle, we'll put this here. I go from one end to another, and it still doesn't read. So now I'm going to go to this end, and if I go here, you can see I get a voltage drop, and if I go here, I get a voltage drop. So this is the base, and it is NPN, and if I go from the base to this end, it's 0.6778. Okay, this is really important, 677.8 millivolts. And if I go to this one, it's a little bit smaller, 666.4 millivolts. All right. Now, when you compare these, you have a higher voltage and a lower voltage. Whichever one is slightly lower, the lower of the two, that's going to be your collector. And the one with the higher voltage drop is going to be the emitter. So in this case, we've just determined that this is an emitter base collector. I'm sorry, emitter collector base transistor, right? Because the emitter is higher voltage, the collector is lower voltage with respect to the base. So we've pretty much, of course, we didn't put a big load on the transistor, but we've determined the polarity of the transistor, the pinout of the transistor, and generally we can figure that it's good. Now, it's not going to tell us if the transistor is noisy. And then what we're going to do is we're going to go from emitter to collector and make sure that we don't have any emitter to collector leakage or shorts. And that's good. So this is a good transistor. We still don't know if it's going to have noise or if it's going to have, you know, shot noise or failure like that. But we know that it'll at least work like a transistor. And then we can find any other additional problems as we power it up and use it. Now this is another one. This is a C, 2SC 1400. And let's see if it's emitter collector base again. So I'm just going to put my, because it's an NPN because it starts with this, ends with a C. It's a 2SC. And there we go. So there's 6546, 6640. So once again, this is the same pinout. It's an NPN and it's reading good. And you can see there's a little bit of leakage, but that's probably because you're reading across a component. And see how if I go this direction, it doesn't read. And if this direction, it does read a little bit and it climbs. So there could be very slight leakage here, or you're probably reading across some sort of a component. Now, these ones have an A in them. I don't know if you can see that. 2SA. And that indicates that it is a PNP. So now your N lead is going to be the base. And let's just guess that it's going to be the same pinout as this one. So I'm going to put my base, and I'm going to go to the emitter. And of course it works. So 656, 646. So again, we have a good PNP transistor. Emitter to collector's good. That one's good. And we know it's PNP. 47, 57, and good. So there in a nutshell is how you test a transistor. That's the way I do it anyway. Now you can remove the transistors and plug them into one of those little testing devices, and you can figure out all kinds of other things, its gain and all that. But I don't really care about that right away. I just want to make sure nothing is going to short out and destroy everything. The rest of that stuff we will determine as we test this thing. So now I'm going to replace these few parts here, and I'll be back. Sorry about the loud noise, but I have the vacuum going for the soldering fumes. But I thought I'd share this with you real quick. I was digging around in my storage unit the other day, and I ran into a little box that had some tools in it, some spare tools, and I found these that I've been looking for forever. Now, if you look at these two pairs of cutters, they look very similar, except this one has this funny looking piece of metal on it. So what does that do? Well, I'll show you. If I just take one of these and I cut the lead off, you can see it goes flying off into oblivion, and actually it's laying on the floor somewhere now. I lost it. But if you use these, that little metal holds the cutoff piece. Now, some people hate these, but for this type of work, I love it because it just keeps the lead from flying away on you. And you can cut the lead off with one hand without having to hold the other lead so it doesn't go flying. I don't know. Some people don't really care about that, but I think that's pretty cool. So I just thought I'd show you. And again, it is Exolite model 175M, but there are a couple different versions that have the little gripper like that. And just thought I'd share that with you. Okay, I have the parts populated on here and replaced, and I just have this module barely tacked in there just to try it. These new modules, of the 10 pins, it only uses 5 pins. Much simpler design. Like I said, these two Darlington transistors, the current source, and a couple of small passive components, and that's it. So I have it connected to my power supply, which is turned off right now. And I'm going to, again, this thing's going to bias up, and with no heat sink, I don't want it to, it probably won't get real hot, but if you let it sit for too long without a heat sink, those transistors will warm up. But let's bring the voltage up, and it's going to be off until you get past a certain threshold, because these transistors don't all turn on at the same time. So when you first turn it on, you're going to see some DC offset. But as soon as you get past a little, around 20 volts, it straightens right out. And if I turn on the signal, beautiful sine wave. So I'm not going to leave that on very long because I don't want anything to overheat, but it's working just fine. And just touching these. They're above room temperature now, but they're not ice cold, but they're cold. And like I said, I think if I would have left it on for a while, they would have begun to heat up a little bit, even though there's no load on them. But anyway, all set to go. And the DC balance, I replaced that pot, and I just adjusted it a little bit for, to get it to be centered. And good to go. So I'm going to put this one together, and then I'm going to move over to the other side. Okay, I have the other side put together, and if I turn the voltage up, and this is the output right now, we're looking at what would be the speaker terminals, and once I get it up past 20 volts, I'm at 31 volts now, you can see that we do have a DC balance problem, because I haven't adjusted this yet. I adjusted the other one before I showed you on the video. So we're going to go to this pot. Remember, we replaced this with a new potentiometer. And I'm probably using the wrong alignment tool that doesn't fit this particular size pot. Okay. And we're just going to adjust this. Hopefully I will go the right way. Yep. And this is like a 10 or 15 turn pot. So, and you'll see when we get to the middle get to the balance point, it's going to get really touchy. And we're going to go to millivolts. We're going to start. Let's see, I went over. And it's going to get really touchy now. See, I just barely touched this pot. So you could see what I'm talking about. If you had a one-turn pot, how touchy this would be. See how it jumped past the center point? I'm going to set this range so it doesn't jump around on me. There. Now we're getting it. That's the only problem I have with auto range meters. They get really goofy. Let me show you now using one of those null meters. Hold on. Okay, now I don't have to worry about my meter changing its ranges and all that stuff. And yes, you can hit the range button, but you can see when it gets out of the range, the thing goes nuts and really gets annoying. Okay, here we go. See, I went a little bit too far. Okay. And this is full scale plus or minus 600 millivolts. So I mean, it's pretty accurate. You can see we're right on, just about right on 0 now. If you look, very, very close. It's a lot easier that way because when your digital meter's bouncing around and everything, it's kind of hard to see where you are with that. Not that you can't do it, and not that you can't hit the range button and toggle through it and stuff, but you just have to watch that. And the other thing is, if the range is switching on there, it'll make you think that it's way out of adjustment, and it's not. You have to kind of wait for a digital meter to stabilize. So this is one of the things I like these little null meters for. They work really well. That other one that we did the little video on a couple videos ago, it'll do the same thing as this. It's just upstairs on my desk. I keep that one up there. That's my little go-to meter for just checking things out upstairs. If I need to test a battery or need to just check something real quick that somebody brings over and I don't want to come down here, that's the one I use. So that's it. It's all set. And our second module is done. And all I need to do is start cleaning up the front. Now here's the problem. This is not a real easy chassis to work on. All this has to come out so that we can get to this board. You can't really take this part off. I mean, you can, but there's other things that'll you'll interfere with. So I'm going to just very gingerly remove this back cover and just take this phono stage and the line stage out so they can be reserviced and recapped and whatever. All right, this is not my idea of a service-friendly amplifier. I mean, it comes apart, but yeah, it looks like a mess, doesn't it? It's like a train wreck. Horrible. But now we're into it, and we can get all of these capacitors changed out, check some things, make sure everything's good, clean the controls properly, and then put it all back together. Actually, this total carnage only took about 5 or 10 minutes to get down to this point. Now, the question is, will we be able to get it back together? And how long will that take? I don't think it'll be horrible, but you never know. Okay, after replacing this many capacitors, the boards are all done and the controls have been sprayed and cleaned. Everything looks good. I just kind of spot checked all of these transistors and things because I just want to make sure that there's nothing that is going to require me to take this thing back apart again, because it's a pain. It doesn't really take long, but the thing that scares me about this is there's so many of these brittle single conductor wires that, or single strand wires I should say, that just, if you work harden them too much and bend them, they'll just break. So I really don't want to stress this any more than I have to. So went through it, looks good, controls are cleaned. I'm going to put it back together. Okay, as you can see, left channel is reassembled, and we have the new Pyramid Audio module installed. We tested it prior to putting it in here, so we know this circuit works. It's generally balanced. Of course, when we get full power to it, it may change a little bit, so we may have to readjust DC balance, but that's not a big deal. Now, before I install the right channel, I'm going to need access to this. If I flip this over, you're going to see what I'm talking about, and of course we have to do the power supply as well. But let me flip this over. So as you can see, these two boards are not even with one another. So this is the power supply for the left and the right channel. These are the big filter caps. And on the other side of this is there's rectifiers and all kinds of, there's components on there, and even other smaller capacitors that need to be changed. But you can see where this has had some serious work on it, especially this board over here on the right channel. So not only did the left channel have issues, but so did the right channel at some point in time. And you can see somebody broke off the post and trashed the track there. And you can see they just kind of blobbed it onto the bottom of the capacitor, and you can see the tabs are snapped off on the caps. I think they needed to get in here to try to service something and just didn't have the right equipment to desolder everything. But both of these are going to come out. I am going to replace all 4 main filter caps and rebuild these 2 boards and then put them back in properly. And the biggest issue with that is going to be the, getting all these wires out and then getting them back in properly. But that shouldn't be too bad. Take a lot of pictures and we'll be good. And that is going to be on the next episode, because I'm going to close this one out right here and get it up and edited. And as always, I wish you all peace, joy, happiness, and good health in your lives. And hopefully on the next episode, we ought to have some music coming out of this thing. So until then, take care and stay well. Bye-bye.